this energy from the sun, we can tell our students, because to our students, they may feel that, okay, energy may be something we eat and make up the energy. Okay, that is also energy. The very true that produce the food that we eat also, produce the energy that is important. But the most important energy for the entire globe, for the entire earth to govern, or to to have these processes like the weather and climatic conditions to happen, the energy that the sun energy, and sometimes we also call it like electromagnetic radiations. Sometimes we feel like if we ask the child, then they won't be able to understand. They won't be saying that, but they will say that in the easiest way, like in the layman language, they can see a light, or feeling of heat, or a light can be sun energy. So that is also true, but in magnetic radiations to so energy is nothing. In physics, we talk like energy is nothing but ability to do work, isn't it? So when a child reaches school, he has a lot of activities, as you can see in the screen. Energy, with the help of that energy they consume, now they can do the activities. They're able to sing, they're able to do sporting, they're able to run around, they're able to sit in their chair and listen to you. Those all required an energy. So that is how we can connect, isn't it? The energy from the sun is something very important for the entire earth systems to govern, or the entire earth systems to keep on changing its environment and weather and climate system. Energy that we receive from the sun is very important for the photosynthesis. The food that we eat, the food that we get, entirely comes from the plants. So there is an interconnection, which I'm not going to discuss here, but energy that a child has. Now we can discuss an energy with students. So if they can jump, if they can run around, if they can read, if they can sing, then that means they have energy and they're using the energy. Now, next, we will tell them that energy is used to, make things move faster. Make things move faster. Supposing a car is moving very fast, that means it is what? It is consuming the energy. The energy that is there in the car, it is being consumed, and it is running very fast. Supposing you ask them to change your directions. Supposing a child is running and you ask them to change your direction to left side, or on the rehearsal of the 15th August, or in the Republic Day period, we moved, we changed directions. For all those directions and movement, what we need, we can ask the child, and then the child will say, yes, it is the energy that we use. And also, if you look at the geosphere, we have known that at one point of the time, the entire continent was one. It's one planet, and it breaks apart and it's spread up. And we have studied these things in the sense like in geology, or some science like the continental drift theory, plate tectonic theory. They all explained how the continent have drifted apart at one point of time, and it is said that these continents are still moving. The continents are still moving. So why is this continent moving, and how this big continent break apart? They all need energy. They all need energy. So this is how, in a very simple way, we can connect energy, connect the students with what is an energy. But to understand the energy, or to understand how the atmosphere or heating of any substance happens, we need to understand the atomic and molecular level. Atoms and molecules level. We need to understand these things. We need to understand. Unless we understand these things, we will not be able to understand how the heat transfers. Right. So I'm not going into detail of what is this and what is that, or what is an atom, or what is a molecules. But in a very simple way, we can even relate these things to our students. So we have to keep these things in mind of the students, that all substance, the substance below to the entire substance that we can see, are composed of extraordinary tiny jingling atoms. Atoms is there in all the substance, and these atoms are not constantly sitting under atoms. They are jingling, okay, constantly jingling atoms, and which commonly bound. This atom bonds together to make a molecules. So these things, I think it is not very difficult things to make students understand about it. Atoms combine together to form a molecules, and the state of this substance. No substance, like example, we take one substance example like so state of those substance, whether they are liquid or solid or gaseous, right? So it depends on the part of how vigorously these molecules are moving. You can see here, I don't know whether it is making any sense or no. You can see the molecules are, shaking, is jingling in the substance. So the entire jinglings will depend on the movement, how vigorously this movement is taking place. All right. So because of this constant movement, the molecules in all substance possess energy. See, this substance, the molecules in the substance, like example, we'll take example of this. These molecules are, jangling back and front. Back and front is moving back and front. And this movement indicates that they have an energy, right? They have an energy. We can simply tell our friends, our students, that if something is moving, that means it indicates that these molecules have the energy. Likewise, so because of this constant movement, you can see here, the molecules of all substance possess an energy. That is very clear. So this kind of the internal energy that the molecules have is known as the kinetic energy. So I think we can make it very clear to our students. Or the kinetic energy, in other words, is what? The energy of movement. The energy of movement is nothing but a kinetic energy. So these are movements. You can see the movement dilate, or simple words, we can say that this movement energy is known as a kinetic energy. See, because we cannot confuse the children. We cannot confuse the children. So this is how we can, explain to our children through these pictures and diagrams. A child is moving around. Now, see, we have a constructivist classrooms, though it is sometimes our students say that it is difficult to control the students because they become extraordinarily active, isn't it? They become extraordinarily active. When we go for internships, children become extraordinary active. See, this activeness in them shows that they have an energy. So in this energy, you have a very strong kinetic energy. We can put it in that way also, because kinetic energy is nothing but energy of movement, right? So that is how we can, take these things to the classroom. So the average amount of kinetic energy possessed, you can see possessed by any child, or by the molecules, let's say the molecules in a substance, is closely associated with the physical properties, and that we often readily sense in our everyday life. Supposing here is one example that I wanted to show. The other one substance is very cold and the other one is very hot. Here, it will depend on the physical properties, right? It depends on the physical properties. So one is very hot, the other one is very cold. When a substance, become warmer, become warmer, supposing this become warmer and warmer, then what does it indicate? That indicates that the kinetic energy of the molecules of that substance is increased. So kinetic is increasing. The more the things become warmer, then kinetic energy is becoming is a substance in that kinetic energy is increasing. You can also see here how the heat transferred, and this indicates that the kinetic energy of a substance is increasing. This indicates. Now coming to heat and the temperature, what is a heat, or what a temperature is all about? They are same. They are same in a sense. They are related, right? They are related, but they are not same. These things have to be clear with students. Heat and energy are related, but they are not same. Okay, so many times we get confused. So heat is referred to the energy presence in the molecules. The molecules movement that we see, we can even show to our students, refer to the energy of the molecules of an object. This object that we see, so heat is referred very easily. It is referred to the energy that is present in the molecules of an object, the object that is moving. So heat is affected. So therefore, heat is affected because it is the energy that is inside the molecules. So heat is heat can be affected by the speed of the particles. If the particles, the speed of the particles slow down, then heat also will slow down. If it increase, the heat will increase. And the number of the particles present in the substance, if the numbers of the substance is much, then that also will increase, and less. So it will depend on the number of the particles also, and the type of particles. What type of particles is there in the substance? In the substance. So this depends. These three things influence the heat of a substance. But temperature is different. Temperature is a measurement of energy kinetic, measurement of the average kinetic energy of the molecules. Now we have to measure the temperature is the measurement of these molecules, movement of the molecules. And this temperature will not be affected by what we have already said, like number of the particles or size of the molecules. This won't. Now here I wanted to show you one example. So this is the temperature now. See, it will depend. The temperature will depend on how fast these particles are moving, how fast these molecules are moving in their substance. So that is a temperature. But when it comes to the heat, it will depend entirely on three other things, like the speed of the molecules, the number of the particles that is present in substance, and the types of the particles. So it will depend on that. But temperature is different. The more the speed of these molecules, the temperature will increase. Here, one example that I just wanted to know that we can also take this into a classroom about the heat and temperature. Now, we have two coffee. One is a coffee mug, and another one is coffee jug. They are filled with coffee of same temperature, right? Of same temperature. Now you can see that the temperature is the same, but the thermal energy is higher in the jug because there is more coffees. So these things is easily, demonstratable. We can easily demonstrate these things in the classroom by showing the same, coffee with one in the mug and one in the jug, and we can say that, why? Because the jug has more, quantity of the coffees, and therefore it has more thermal energy. But when we look at the mud, it has less quantity of temperature. Ji sir.
Yes, sir. In between, your voice note was audible. That is why.
Oh, child. Now is it audible?
It is now. No.
Okay. It may be because of network issues, sir. It may be because of
yes, sir.
Yeah. So now it's audible, right?
Yes, sir. Yes.
Okay. Thank you. So we have already discussed the concept of what is heat and what is temperature, differences between the heat and the temperature. Now, these things are easily available. I mean, it is available in all the schools. I'm sure your schools, the place where you are teaching, also will have these things. See, today we have a gadget, and early morning as you wake up, you have a mobile phone to see what will be the temperature of today. If you go to your classroom and sit in your classroom and check your temperature, it is there. But practically, we cannot, we cannot replace this type of instruments, the thermometers that we have, the instruments which we use to measure the thermometer. But we have to make things very clear to the students. Students को ये जानकारी और clarity देना बहुत जरूरी है कि there are three scales. There are three scales by used by different countries at different point of time and different time. So we see that a Fahrenheit scale is also an instrument to measure a temperature, but which is not used, all over the world. But in India, we use both Celsius and Fahrenheit scale. But we usually go for, weather reporting and all those meteorological reporting. We go by this Celsius scale. But sometimes, our instruments comes. You can see here the Fahrenheit, which I have in geography lab. This is the Fahrenheit which we have, and this is the Celsius. So likewise, in other meteorological instruments also, sometimes we even go for this Fahrenheit. But usually our reporting, all the temperature that weather system reporting goes by the Celsius in India. This Fahrenheit has a special, implications or special utilization in the United States of America. It is mostly used in the United States of America. Supposing if you're watching CNN's news in the morning, then you will come across the temperature like 80 Fahrenheit. So one should not be confused. One should not be confused or 100-degree Fahrenheit the temperature today is. But Fahrenheit and the Celsius has huge differences. So if it is 100 Fahrenheit degree, then it indicates that in India, for our scales like Celsius scale, it will be around 40 degrees Celsius. So this is how differences that we should let our students know about it. And although there are other scales which is not used at all. So like the Kelvin scale is also used, and this Kelvin scale is used because it is measured. It measured what we call as absolute temperature. Right? It measures absolute temperature. That is why it has been used. Otherwise, it has not been used by many of the countries. So you see that the scale which is there here, then the weather conditions of your room temperature of your areas. So this is a very important thing, and I have a small. RI Bhopal is going to have a weather station very soon, and it is going to be sponsored by the Department of. So likewise, you can even have touch. If you let it burn for another half an hour, then it will be very dangerous for a student to touch because it may give a burning in their hand. Your port will be a bit able to give there some conductions. So let the student touch it, and they will experience, okay, I feel the heat, so that become a conductions. But conductions in the atmosphere is not very important. Convection and radiations. This conduction, because conduction in the atmosphere is not very important, because air is a very bad conductor of heat. Air is very bad conductor of heat. So what happens is that the air which is just nearby the Earth's surface, say a few centimeters from the Earth's surface, they will have the conductions because Earth is warm. We have to keep in mind that the Earth is warm. And another important thing that we should tell our student is that every substance has emit thermal energy. We all emit thermal energy. So Earth also emits thermal energy. Earth also is a heat they receive from the sun. So this the air, which is very much near to the Earth's surface, will have the conductions. Otherwise, it will not have much conductions if it goes up, because air is not a very good conductor of heat. So this, in meteorological sense, this conductions has little or less, influence on the atmospheric phenomena. The next thing that we can discuss with our student is the convections, and this is very important. And convection is a very important. If you can show this when if you have a transparent pot, and you started boiling in water, and slowly the water bubbles will start to come up, and then it will go down. It will come up and go down. That is convection. That is happening, and convection is happening because of the radiations, the heat that has been, hit the pot, and the convection started. The hotter part, this hot water bubbles will go up, and it become cold later on as they reach the surface and it goes down. And this is how the convections took place. Now, how is these things, the convection in atmosphere important? See, like we have a picture here. Supposing in a very cold winter, we started using it. ये सब बच्चे को भी होता है. घर में क्या है? Winter season आ रहा है. Winter season is almost reaching by next month. By December, winter will start, and then by winter we started using heaters in the room. So when we use heater, this is the first thing that I wanted to show here. This is winter. We have a room heater. So that when we when we on this room heater, the air, supposing this entire room is now very cold, then the air started to rise up. Why? Because we know that the warm airs are lighter. That is why they go up. So this air started to move out, and it reached certain time, and then when it meet the cold air, then it become what? They become heavy, and they started to, this become empty. This area become empty because the air become hot and it has gone up. So this has become empty. So the cooler air was started to feel this happening, and that is the principle of convections. The convection principle that we see in geosphere, we see that in convections. The scientist says that in the astronosphere, the convection cell is there. The convection is happening. Since we know that there are always the convections happening. The warmer one is going up, and when as they reach the bottom of the lithosphere or the air crust, they become cold and they started to move down again. So these convections are happening. And in the beginning, when I show you that the entire continent was once upon a time one continent and it break up, the scientists are of the view that they break up because of the convection's energy, So the entire breakup is because of the convection energy. And this is how I know, we can explain to our students about how this convection energy is happening. Another example of the convection is, you can see that, the vapors are going up, and these vapors are nothing but the hot air. They are going up, and what is happening? The colder air that is surrounding them will fill up this, they become warm and they go up again. And when it becomes cold, it comes down. And this is how, the convection cells are produced. The congestion cells are produced. We often come across like convectional rainfall, isn't it? We come across convectional rainfall or relief type of rainfall, or sometimes we have, cyclonic rainfall. These are the three principal rainfall system types that we will see in the entire world, right? One is a convectional rainfall, the other one is the orographic rainfall, the other one is a experience every year when the rainy season starts. Cyclonic start, orographic start, but these two things I will keep aside, and we will discuss little bit about what is a conventional rainfall. So the same thing happened, the same principle applies. Just like we apply this principle here, this bubbles going up, the vapors going up, and it has been filled by the cool air, and this is how the circulations are happening. So the convectional rainfall also have the same principle. The warm vapors is going up. After certain time, after certain limitations, they reach the saturation point. And in meteorology, the state of atmosphere in which air contained the mixed maximum amount of water vapor. Saturations mean there cannot be additions of any water vapor anymore. That means it has reached its saturation point. Beyond that, if it goes, then it started the precipitations, different precipitations. So those type of precipitations can be known as a conventional rainfall. The vapors are going up after a certain limit. They got a saturation point. The clouds are formed. We can show our children the clouds in the sky. You can explain to them that these clouds are nothing but aggregations of the water vapors. And more water vapors are added. They cannot hold anymore. So in the form of precipitation. So this is how we can practically involve students in our teaching learning process. And